Hello. In the previous videos, we completed iteration 3, and you notice that originally we thought in iteration 3 we're just gonna set up the game, and in iteration 4 we play the sound, but we actually did play the sound. The random note implemented that in iteration number 3. We're not done. We still need to do the end game and so on. So I can come here and modify iteration number 4 here and the text of iteration 3 and 4. So I'll say that this is the still the game setup and play the random note and the evaluation. So that's like a first run on the entire game. And in iteration 4, I need to implement the end of game and enhance or implement the visual representation for the evaluation. So we're gonna work in this video on iteration 4. We say here iteration 4. And first thing is the problem formulation to define the scope and how are we going to test it, and research as well. Don't forget the research. I have done the research before I show you this, because research takes a lot of time and I don't have that time in the video or in the class. But if you're working on a project of your own, you will need to spend the time on doing research on specifically what you're looking for from the initial problem. So here I'm jumping into the scope. So in the scope here, we need to implement end of game. So we'll need to implement image display for correct and incorrect answer. And that will be it for this part. And the testing here is easy. We need to run a game and see if the dialog come. In the previous iteration, when the game ends, nothing changes. If end of game is displayed, and we'll need to implement correct answer and incorrect answer to test the visuals. So we move to solution formulation. In the model, and we have in the model, in this case, we need an alert, which is, if you remember the mockup, in the end of game, the user will get an alert dialog that says it's end of game, and they click OK here. So this is an alert dialog. So we need to find a component that will be used to display that. And this dialog cannot be set up at the design time in the storyboard, so we'll need to create that ourselves in the in the actual Swift controller. So the library that UI alert view can be used to display that that dialog, and at this time you want to spend time learning about what the alert view is and what it does. We're also going to use images for correct and incorrect. So the images need an image view, so we'll need to add an image view, although this is probably more on the view, because we're going to add that in the storyboard. So we can jump here to the view. So we need to add image view components for 2 images. In the model, we probably need to add the image files add the image files to the project, and then we need to add the image view here in the view. We may also need to add another label to display the how many turns. Add another label to display how many turns, the current turn. And in the view as well, I'll try to color the label text green if correct and red if incorrect. Just another visual to the user. On the controller, the different function stays the same. We have the same structure. So we need, when the game is over, we need to implement the dialog, the alert view. When checking answer, so in the check answer, we'll need to display correct answer image. So how do we display the image and then undisplay the image after that? The image view controller has the alpha property. Remember alpha from project 2, which is responsible for the transparency or the opaqueness. So alpha 1 is an opaque view, you can see it. Alpha 0 is a full transparency, which means it's blended with the background so you really can't see it. So if I can play with the alpha, so I start with both images at alpha 0, meaning you can see them. And if the user have a correct answer, I set the alpha to the correct answer image to 1. And if the user has an incorrect answer, I'll set the alpha to the incorrect image to 1. Learning from the previous iteration when we use the label, this means I have to reset the alphas as well to 0. Same thing, I reset the label to nothing between the turns and between the games. So I'll need to, in the reset turn, I need to reset the alpha to 0 for both image views. When taking an image at an alpha 0 and turning it at an alpha 1, that's a transition. So anytime you have a transition like that, we can animate that transition over a period of time. So instead of instantly turning from 0 to 1, we can have that take some time. So we'll learn how we can animate that transition from 0 to 1 in the alpha as well, using the UI view begin animation. So in the UI view, there is a function called begin animation block and commit animation, which basically works, and you will see that better when we implement it, allow you to define a block, and anything inside that block will be animated if it has a transition. So we'll need to implement that in the check answer. So we'll need to implement something in the play game, implement something in the reset turn, implement something in the check answer as well. So when we go to the solution implementation, we'll say that in the play game, we need to add alert view when game is over, which is the else block. And you can see that here, the else block. Then in the reset turn, actually before this, and I should have wrote this here, we need to add 2 images as resources. Then we need to add image view to the view, and then we need to add a label for the counter. And I'll probably should start this over. So this is the solution implementation. And in the view, before the view, even in the resources, need to add 2 images. In the view, we need to add 2 image view and connect to the images and set alpha to 0 for the beginning. Then we need to add label for the counter, and we need to connect all as outlets since I'm going to change their conditions and their properties. Then in the play game, implement the alert view. In the reset turn, reset the alpha. In the check answer, change the alpha to 1 for the correct answer and change the color of the label, and then finally animate the change. So let's see how we can do that. So first, to add 2 images, right click on the project file and say add files to the project. I downloaded 2 images here in pictures. One is correct answer and one is incorrect answer. Make sure you say copy items so that I have them here in my pictures folder so that they are copied into my project folder. So when I zip this project and share it or submit it, it will be there as well. So here are the 2 images. And then the next step is to go to the storyboard and add 2 image views for each one of those images. So I look for an image view and add an image view here. And the image view takes an image. So because we added both images, they are here in the drop down. And I want to initialize that image with an alpha 0. Then I add another image view and I'm going to add it right on top of it. And we'll initialize this to the incorrect answer and set the alpha here to 0 as well. Then I need to add a label. So I'll add that label. And you can set the colors and everything if you would like to change them. And I don't want label to be written on it. So now I need to set them up as outlets. So bring in the assistant editor. And I don't really know which one I'm clicking for the label. I know it is this one here. So I can click Control and drag the label. And I'll leave the outlets together and I'm going to call this label counter. So this is the label that will have the turn counter. Then I have 2 images, but I really don't know which one it is. You can see it over here, or you can bring the document outliner, and maybe I need to hide the project explorer. Bring the document outliner and you can select from the document outliner and control and drag from the document outliner to the controller. So here we're going to call this image view. I'm going to call it correct answer image. And then another one, the incorrect. So drag that incorrect. I need to insert it. Incorrect answer image view. So that adds the all the outlets. So that is done with this resource and the view. So now we go to the play turn. So let me bring back to the main view, bring the project explorer view. So we go to the play turn. So what do I want to do in the play turn? Here, end of game. Nothing is happening at end of game. So we need to add the alert view. Add an alert view. So the alert view is of type UI alert view. And you can initialize an alert view with different, you can have an empty one, you can initialize one with certain size, or you can initialize one with some functions, like with some parameters or arguments, like title, message, delegate if you want a specific delegate, and the cancel button. So here we'll say what is the title, end game, that's the title. What is the message? You can provide the message as a string literal like we did with the end game, or you can define a variable as a string and use it here as your message. So let's start with game is over for now. The delegate, we don't have any delegate, so there is no delegate. And what do you want the cancel? Cancel here is the dismiss, because in this case, we're not giving the user an option, yes, no kind of thing. We're just dismissing it. So we'll say, okay. So the user, the button that the user click on it will say, okay. That creates an alert view object. So I need to assign that, and I'm going to call it alert, assign it to a local variable so I can use it. Once you create the alert view, then you can display the view. So you say alert.show, and this means that it will display to the user click on the OK button, so it will dismiss. When it dismisses, it comes back to this start game method here, and it keeps waiting because the game is now over and the user can click start game to start again or to play another game. So that's the display of the dialog. Then in the reset turn, we need to reset the images. So here is the reset turn. We reset the label. We'll need to reset the other label as well. The label counter, the text. This also needs to go to nothing. Then you have the correct answer image. See, it's difficult to remember the name if I prefixed it with image or something like that, like I do with label. I'm kind of filtering the methods. So I'll say here alpha and say 0, and incorrect answer image view alpha also to 0. So that's this one. Then check answer, that's where some of the work is. I have two things. The first one is I need to change the color to make the label and text is has a different color. So I'll say label answer, not counter, label answer dot text color. So here is the text color equal. So we need a color. There are some constant colors in the UI color object. So if you say UI color dot, there are some colors here. I want a green color. So here is a green color. So these are called class methods or class functions, which I don't need to create a color object if I want to use any of those standard colors. So I use green color. If you want a specific variation of the color, you know how we initialize the color using the red, green, blue, and alpha, and you can use specific values to get a specific degree of color if this is important to you. Then in the label answer in the else, so we'll say the text color here will be the color red. So we're calling the red color function on the UI color library, and that will create a color red, and then we assign that to the label. The other thing we want to do if it's a correct answer is to display the correct answer image. So we say correct answer image dot alpha equal 1. If it's incorrect answer, then we want to display the incorrect answer image. So So we say incorrect answer image alpha equal 1. All right. Finally, it is the counter. So in either way, whether it's correct answer or incorrect answer, we want to set to display the counter. Display the counter. So I'll say label counter dot text equal, and then you can construct a message or use a string literal. So we'll say this is attempt, and then the number of the attempt, which is the turn counter. So I can incorporate the value of turn counter here inside the string by using a slash parentheses and use the value, so turn counter. So this will insert the value of turn counter inside the string. You can also use what we did in project 2, localize the string with format. If here this is an integer, so there isn't really much formatting. If you have a specific formatting, then you can use the localize string format. And now I'm going to say this is attempt such and such out of, and then the maximum turn. So this will be max turns. So that's this part for the check answer, except the animation. Now here is the change. So before that step, the image view alpha value is 0. This step will set the 0 to 1. We can animate that by including this entire block. Really, I want this line is the one to be included in the block, but that one too. So instead of making 2 animation blocks, I'm just going to put everything in here inside an animation block. So compare the 2 nodes. Before I do that, I'm going to say begin an animation block to animate the image display. So I'll say UI view dot begin animation, and the begin animation requires a name. Like if you in your program have many animation blocks, you can identify them by name. So here I don't really need to give it any name, so I can say nil, or I can just use anything and animate. In the context, there is no context. I don't need a context here. And then the end of the block, I'm going to have it after the if the statement, and this ends with commit the animation. So I'll say UI view dot commit animations. Now, what are the properties of the animation? So we need to set animation properties. And perhaps we can indent to the right and have the animation properties. So I'll say UI view dot set animation, and here are the different properties that you can have. You can have an animation curve, you can have a delay, a delegate, duration, and so on. So duration is the one that I want, and the duration meaning that this is how long it will take for the image to go from 0 to 1. Notice that I am pausing the user at the check answer for 2 seconds before another sound is played. So you want this duration to either be the full 2 seconds or a little bit less. Maybe I'll make the duration 2 seconds, and instead of waiting for 2 seconds for the second sound, maybe make this 3. So the image will animate over 2 seconds, then the user will have 1 second to reflect before the second sound plays. So that's the last part here. So let's test. So I have 2 tests that I want to make. Number 1, see if the actual alert view will come. And the second test is I want to know if I got a correct answer or not. And I won't be able to do that without maybe logging the actual answer. So here, start the game. So I heard the sound. Let's say this is this. So it's incorrect answer, attempt 1 of 3, another one, incorrect, attempt 2 of 3, and attempt 3 of 3, it's incorrect, and it's end the game is over. You click OK, the user is back to the game. So now we have a full game cycle here. The second test I wanted to do is to see if I'm actually making a correct answer or not. To do that, I might log so that it is displayed what is the current node. So here is my current node. So I can come here and say log the current nodes. This prints it and you will see it anyway. But the log is happening with something called nslog, which takes a string and some arguments. So the string here will be current node is, and then %at. This is the format specifier, similar to what we used in project 2 and 3 for the text. The at means that expect a string as an argument. So you can have many arguments. Here the string will be the actual current node. So this will print to the output screen, not to the game. And you will see that output screen in a moment. What is the current node? So we can see if it's a correct answer or not. So now when we run, we start a game, we hear a sound. When you hear a sound and it's the output screen, but I didn't see it, if you bring in the note, so the current note was E, the first one, the next one is G sharp, so we'll use the G sharp, so now it's a correct answer. And then the next one, here is the current note, so I can make a correct answer. Yeah, I am cheating, but I'm actually testing, I'm not playing the game, so I need to make sure that I am testing all the possibilities and I'm testing them correctly. So that's what we have here, and this will end this video. In the next video, we will work on the score, and then the one after we'll do some enhancements. So until then.